So, good afternoon, everyone, and welcome to this lecture. This is lecture number 6, when we are into electric current. In this class, we will try and move on to those electrical instruments and, if possible, wrap them up by today. Now, in the previous class, we had seen what we had seen. We were looking at questions where we were trying to find out simple things. We had seen how do we find out the internal resistance of a battery when the battery is getting discharged, and we must remember these things because these things are going to come in this particular section that we are dealing with, because we will be using devices to calculate this. We had done some questions as well where we had found out the internal resistance of the battery. Do we remember these questions, everyone?
Yes, sir.
Okay. Remember the concept that we had seen to find out the internal resistance of battery. It was E by V minus 1 times R, where R was the external resistance that was connected. We will be using this, as I told you, in things that are coming up in today's class, probably, in all probability. Anyways, having talked about electrical instruments, what are the electrical instruments? Electrical measuring instruments that you have heard about. Have you heard about any electrical measuring instrument? Have you heard the name of any electrical measuring instrument? Huh? No one knows.
Ammeter, voltmeter,
Ammeter, voltmeter, and
galvanometer.
galvanometer, rheostat, all these meter bridge, potentiometer. Heard about these meter bridge, potentiometer? All these are electrical measuring instruments, and they do certain specific jobs. So we'll try to see them one by one, and the first one that comes into the line is what? What is the first electrical instrument that we should worry about? Not worry about, talk about. What is the first type of electrical instrument that we must talk about? Hmm. What is the first electrical instrument that we must talk about? Huh? The simplest of them. And what is the simplest of them? The simplest of them happens to be ammeter. Now, what is an ammeter? And what does an ammeter do? Ammeter is normally denoted by this A in a gola. That is the symbol of ammeter. What does an ammeter do? Yes. What is an ammeter and what does an ammeter do? Anyone?
Measures the current inside circuit, sir.
Ammeter is a device that measures the current in the circuit, and this is how the symbol looks like. The only thing that it does, it measures current. It measures current. Now, to measure current, it must be connected in series in the circuit. It must be connected in series in the circuit, because if it is not connected in series, it will not be able to measure current in that particular branch or that particular line. Now, every ammeter may have a range. Range means what is the maximum current it can measure. Do we understand this? Whenever you see any electrical device, it has a power rating, it has some rating. Ammeter has a range, and that range gives us an idea of where you can use this ammeter for measuring what values of current. I hope you understand this. Yes or no? Huh? You understand this? First listen to me, then I'll give you the time to write. Ammeter must be connected in series. Now whenever we talk about ammeters, we might come across two types of ammeter. One is known as an ideal ammeter. Obviously no one is ideal, and the second one is known as the real ammeter, or the ammeter which is normally available. What is the difference between an ideal ammeter and a real ammeter? Hmm?
Ideal ammeter will not have any internal resistance. Real ammeter will have internal resistance.
Yes, ideal ammeter, the internal resistance of that ammeter is zero, which is basically not possible. The resistance of this ammeter is not equal to zero. Every ammeter is an electrical device. Every electrical device is a resistor or a capacitor or an inductor or a combination of all these three things. For an ideal ammeter, it only exists in the ideal world. No world is ideal. The resistance must be zero. Therefore, if the resistance is zero, if we take it as an ideal ammeter, and unless and until it is mentioned otherwise, the ammeter will be always taken as ideal. It will measure the true value of current in the circuit. Exact value of current it will measure. But if it is a real ammeter, then what will happen, that because of the resistance of this ammeter itself, the current would be distorted and it will not measure the actual value of current. In fact, the value of current that it will be measured, it will be slightly less than the actual value. Do we understand this? Yes or no? We understand this?
Yes, sir.
Okay. Have we noted this down? Okay, I'll give you 2 minutes. Note it down. Let me know once you are done. Very good. Absolutely correct. The next one is a voltmeter. Now, what does a voltmeter do?
Measure the potential difference, sir.
Voltmeter denoted by V, V in a gola. Uh, this is how a voltmeter looks like. Everyone knows it, but I'm just showing you the diagram so that I don't skip or leave anything. If I leave or skip anything, it might have disastrous result. Okay, voltmeter. It measures the voltage drop across 2 points, and
Always connected in parallel, sir.
it is always connected in parallel. And every voltmeter will have some range. That range will mean what is the maximum PD or potential drop it can measure. Now, whenever we talk about this voltmeter, there will be two types of voltmeter. Unless anything is stated, we will always take the voltmeter to be ideal. What are the two types of voltmeters? Ideal and real. Now, what is the difference between an ideal and a real one here? Yes. For a ideal voltmeter, the resistance of the ideal voltmeter should be very large, almost infinite. Because when it is very large, almost infinite, the current that this voltmeter draws, which is shown as I here in the diagram, will be almost zero, and then only it will be able to measure the actual potential drop. If the resistance is not very large, it will measure the potential drop, but that will not be the actual drop, because some current it would be drawing for itself. Do we understand this? So for an ideal voltmeter, the resistance has to be infinite. Unless otherwise stated, every voltmeter will be taken as ideal. Note it down, I'll give you 2 minutes to do that. So let us try and understand what difference does it make when you put a voltmeter across a register. So this is a question and it is taken from your favorite book, SCV, and I hope you would be able to do justice to this question. I hope everyone can see this question now on your screens. Anyone can see this? Yes or no? Or shall I make it bigger? See this?
Yes, sir.
Find the potential drop across the two resistors shown in the figure. So in the part A of the figure, we have got one battery and two resistors connected. We have to find out the potential drop across each resistor. Then in the second case, a voltmeter of resistance 600 ohms. A voltmeter of resistance 600 ohms is used to measure the potential drop. Remember, it is not an ideal voltmeter because it does not have infinite resistance. A resistance of 600 ohms ka voltmeter is used to measure the potential drop. What is the measured potential drop? And then you will see what is the difference between the two readings. I'll give you 2 minutes to give me the answer for this one. Too much of time, my dear friend, you have consumed on this question. Too much of time. That much of time you don't have. You have to find a potential drop across this one, V1. You can very easily do it. It's just a two resistors in series. So this V1 will be equal to 300 by
R1 by R1 plus R2.
how much time should you take to do this? 5 seconds, 3 seconds, 4 seconds, not more than that. This is 60 volt. So this one will be 40 volt. 2 to 3 seconds. More than enough to do this. Now, when it becomes in parallel, 600 and 300 come in parallel, it becomes 200. Both are 200. So equal voltage, 50 volt. How see, I've taken so much of pause, I've taken so much of time, still I could do it in 5 seconds. And you fellow have taken 5 minutes for this. Eh? Useless. 50 volts is the potential difference that we find when you connect a voltmeter of resistance 600 ohms, and that is way less than the actual voltage, which is 60 volts, and therefore this is not an ideal voltmeter, and therefore it is not measuring the correct voltage. I'm very disappointed with how you have solved this question. Very disappointed. Okay, what's the use of giving you all those things when you just cannot use it? Useless. Absolutely useless. Huh? Anyways, I have to keep the disappointment on one side and I have to move on because I need to cover the course. Let's see if you can do better in this one. Again, this question emphasizes on the error that we have because of this instrument. So this is the question coming up. Find the current in the circuit. Also determine the percentage error in measuring the current. What is the percentage error? On the left hand side, you have the original circuit and you will have the original current. On the right hand side, you have a emitter connected, but this emitter has a resistance. So it will change the current. You have to find the percentage error. 0.5 ohms is the resistance of the emitter. You have to find out how much is the percentage error. And I hope that you can do this in at least 1 minute or 2 minutes, the time that I give you. Hopefully, I'll get an answer quickly. So how are you supposed to do this? You have to first find the original current. Original current you will find out is 5 amperes moving like this. In this circuit, because of the emitter having its own resistance 0.5, the total resistance becomes 2.5, the total current becomes 4 amperes. So the current has changed by 1 ampere. So 1 divided by original current is 5 multiplied by 100. So you can see there is a 20% difference in the original current. That means you should have an emitter which has even less resistance. Otherwise, the error gets on compounding. Do we understand this? Yes or no? Huh?
Yes, sir.
Yes, sir. I'm not pleased with what you are doing. And I hope that you can prove me wrong in the next question. This is the next one. What is the reading of the emitter? Is this the current to the 6 ohm branch? Obviously, it's not the current to the 6 ohm branch. So this is just to prove that you have to put it in series. So you have to find out the reading of the emitter, and I'll give you a minute to do this. So how are you supposed to do this? You have to find the reading of the emitter. So this emitter has a resistance of 3 ohms. This is 6 ohms. 3 and 6 are in parallel. So we'll have the total resistance as 2 ohms. 2 ohms and 3 ohms are in series. So you have total resistance as 3 ohms. Anyway, you don't have to find out the total resistance. You have to find out the current through the 6 ohm branch and current through the emitter branch. Now the value of the resistance, the effective resistance is this one is 2 and this one is 1. Instead of finding out the current, I can find the voltage drop. What is the voltage drop across this one? The voltage drop across this one will be 18 into 2 divided by 2 plus 1, 3. So that will be equal to 12 volts. The voltage drop across the combination is 12 volt. So I can find out the current through this 6 ohm branch. The current through this 6 ohm branch will be 12 divided by 6. So this will be 2 amperes. The current through the upper wala branch will be 12 divided by 3. That will be 4 amperes. So through the circuit, 6 amperes of current is flowing. You could have done it other way. This is 18, total resistance is 3, total current is 6, and then this 6 current is getting divided into 2 parallel branches. Current divides in inverse ratio. This is how you could have done this. So there are different ways of doing it. I hope you have understood this. I'll give you 2 minutes to note this down. Let me know once you are done. Anyone has understood this, what we have done?
Yes, sir.
Note it down, please. So we have understood this question. The previous one, where we had found out the current through the emitter. Shall we move ahead on to the next device? And the next device that we are going to understand or do is known as the galvanometer. Now, what is this galvanometer? Now, this galvanometer is actually represented by this letter Gola with a G. Now, this galvanometer, anyone has heard about this galvanometer? What does this galvanometer do? Anyone knows anything about this galvanometer? No? Or yes?
Very small current passes through it, sir.
It is a device which can measure very, very small values of current. It's a very sensitive device and it can measure very, very small values of current. So galvanometer is a device, a very sensitive device, and it can measure, it's a very sensitive device and it can measure very small values of current. Very small values of current it can measure. Normally, we use a galvanometer which is known as the moving coil galvanometer. Now, why it is known as a moving coil galvanometer? Because every galvanometer will have some measuring scale, and this galvanometer has a measuring scale, something like this, something like a speedometer. I mean, it's just a representative diagram. Do not make much about it. So every galvanometer has some measuring scale. Now the deflection on this scale will give you how much is the current that is flowing in the circuit, and this deflection in this the deflection in this galvanometer coil, if at some point it is like this, and at some other point when it is put in a circuit, it deflects by an angle theta. It's a moving coil galvanometer because this theta is directly proportional to the current that is flowing in the circuit. That is why it is known as a moving coil galvanometer. Do we get this? So it is known as a moving coil galvanometer because this deflection in this galvanometer is directly proportional to the current that is flowing, and since it is a very sensitive device, it can actually measure very small values of current. The actual principle of this is in the chapter on EMI. We'll see it then. Not EMI. Whenever you have a current carrying coil placed in a magnetic field, it will deflect. That is the actual principle. We will see it in the next chapter. Right now, we can just see that this deflection that this coil will have will be directly proportional to the current flowing in the coil. Do we understand this much up till here?
Yes,
That
sir.
is the working principle of a galvanometer. The working principle is different. We will see that working principle when time comes. Right now is not the time to understand its working principle. Now, every galvanometer has something known as the full scale deflection current. Sometimes it is written as IG, the current through the galvanometer coil, IG. Now, this is the current. Because of this current, this galvanometer will give full deflection here. If the galvanometer has only 3 readings, this is the full, the 3 here will be the full scale deflection current. If a current comes in the galvanometer which is more than this deflection current, full scale deflection current, obviously the galvanometer will be damaged. Do we understand this? Yes or no?
Sir.
So this is known as the full scale deflection current. Now, every galvanometer has got a coil, and that coil has a resistance. So the resistance of the coil of the galvanometer is known as the resistance of the galvanometer. Every galvanometer has a resistance. Resistance of galvanometer G is nothing but written as Rg, which is nothing but the resistance of the coil of the galvanometer. Do we understand this? Do we understand this? Up till here, have we noted this down? Or do you want time to note it down? Okay, we'll give you 2 minutes, note it down. We move forward. Now, since this galvanometer is a very sensitive device and you need to protect the galvanometer, you should not allow large current to flow through this galvanometer, otherwise this galvanometer is going to get boom. We connect a resistance normally in parallel with this galvanometer. Anything which is connected in parallel, and if you study electrical engineering in any college, even in any engineering, the first 2 or 4 semesters are same for all the branches. You will hear a term shunt. Shunt means anything which is connected in parallel. In this case, a resistance is connected in parallel, that is known as the shunt resistance. Anything, anywhere you hear the word shunt, shunt means it is connected in parallel. Do we understand this? Shunt means parallel. Then you can also write the advantages and disadvantages of this shunt. The advantages of this shunt are definitely to protect the galvanometer coil from burning if more current passes through it. Boom. The galvanometer is going to go dong. This shunt also converts a galvanometer into an ammeter, and that is the next thing that is what we are going to see. But what are the disadvantages? Shunt resistance decreases the sensitivity of the galvanometer. Now this is a question. This is a point that I've seen come as question in your JEE, not advanced but JEE main. So you must note it down carefully. I'll give you a minute to note it down. Well, since we have come so far, so there are two more small things that we can write, and I've seen questions on this: current and voltage sensitivity. Current and voltage sensitivity of a galvanometer. Now, what is this current and voltage sensitivity of a galvanometer? It's nothing very dramatic. Now, the principle on which this galvanometer works, and if I just write the equation of that, the equation looks like this: BINA is equal to C theta. So your theta, the deflection, the deflection can be written as B N A by C multiplied by I. Now this B, N, A and C are constants. What is this B, N, A and C? And we will get to know this B, N, A and C in the next chapter, magnetic field. B is what? B is the magnetic field. Inside this galvanometer is a magnet which creates this magnetic field. N, it has a coil. This N is the number of turns of the coil. Number of turns of the coil of the galvanometer. A is the area of these coils. C is known as the torsional spring constant. I must have told you about this torsional spring constant. The spring that is put here in this is known as a torsional spring. Now, normal spring, if you extend it, it exerts a force F is equal to Kx. K is known as the normal spring constant. A torsional spring, when you twist it, it exerts a torque, and that torque is C into theta. So C takes the place of K, and theta takes the place of X, and force takes the place of, and torque takes the place of force. Are you understanding what I'm saying here? What is going above while it's saying bye bye? Huh?
Understanding, sir.
So basically this C, this theta, which is the deflection of the galvanometer, is proportional to I, because B, N, A and C are kept constant. This is just for you to just understand this, because I may be using them in the next scenario. Current sensitivity of a galvanometer, and first listen to me, then you write. The current sensitivity of a galvanometer is nothing but the current sensitivity of a galvanometer, if I call it CI, current sensitivity is nothing but theta per unit current, deflection per unit current. That makes sense, because if for a small current, you have high deflection, that means you can measure more current very accurately. You can measure current very accurately, and therefore your galvanometer becomes sensitive. Your galvanometer becomes more sensitive. Sensitive. Do we understand this?
Yes, sir.
If your galvanometer can measure very small values of current, for small current, it can give you more large deflection, it becomes more sensitive. Yes or no? So this becomes, if I write it from the equation, it becomes B N A by C, because I had to use B and A. That is why I had to tell you what is B and A. This is current sensitivity. Don't write it now. I'll give you time to write it. Then the next thing is voltage sensitivity. What is voltage sensitivity? I've told you what is current sensitivity. Can you tell me what would be voltage sensitivity? Huh? VI. Yes? No idea. Get idea. No idea? No one knows it. It will be theta per unit voltage drop. Theta divided by I, which is the current in the galvanometer, multiplied by Rg. What is this Rg? Huh? What is this Rg?
Galvanometer resistors, resistance.
Galvanometer resistance. So you can write it as BNA by I into R. Voltage and current sensitivity of a galvanometer. Do we understand this, or this has gone above what it's saying bye bye? Bye bye, sir.
Yes, sir.
Bye.
Understood, sir.
Huh? Okay, I'll give you 1 minute to note it down now. So then let's move on. Since we have seen the current sensitivity and the voltage sensitivity, now we must venture into the next topic.
Sir,
Yes?
how C came in second step, sir?
Conversion of galvanometer into voltmeter. Conversion of galvanometer into ammeter first, not voltmeter. Someone was asking anything, I could not hear it. Conversion, anyone was asking anything?
Sir, in second step, we are getting C. How, sir?
Do it on your own, you will get it. Trust me. Try it on your own. You know BINAC theta C5. Try it on your own. You will get it. Don't worry.
In last second step, we will not get C, sir.
Yes, yes. In second step, you will not get C. In the third step, you will get C. In the third step, when I convert it into, when I put the value of theta, then you will get C. Okay. I probably made a mistake in writing.
Okay, sir.
Okay. I probably made a mistake. I did not see it. Anyways, conversion of a galvanometer into ammeter. Now you must understand that this ammeter is actually not an ammeter in itself. It is basically a galvanometer. So the only device that we have is a galvanometer. That galvanometer is actually getting converted into an ammeter. And how do I convert a galvanometer into an ammeter?
And so,
Yes, a shunt resistor, a shunt resistor, a shunt of very small resistance is connected. And then this galvanometer becomes an ammeter. So basically, what you have is, this is This is your galvanometer. This is Rg. You understand Rg? The resistance of the galvanometer. Now what I do is I connect a shunt resistance in parallel with this galvanometer. RSH, R shunt. As soon as I connect this R shunt, this entire arrangement here now becomes a ammeter. Do we understand this? This entire arrangement becomes a ammeter whose range is I. You can call it as capital I. Do we understand this?
Yes, sir.
Now, when this I current flows through this gentleman, the maximum current that can flow through the galvanometer is only Ig. Do we understand this?
Yes, sir.
And the current that flows through the ammeter will be I minus Ig. I mean, through the shunt will be I minus Ig. Yes or no? Then for this, you just have to remember one equation. What is that equation, bacha? You know, these 2 points A and B, the potential drop remains same, whether you go from the upper wala path or niche wala path. So the only equation that matters in this entire thing is Rg into Ig is equal to R shunt into I minus Ig. Everything will be known to you. This I is the maximum current that can flow in the ammeter. So this I will be the range. This I will be the range of the ammeter. Do we understand this? So you will be given what range ammeter you want. From there, you can calculate the value of I shunt. So what is the value of what is the value of R shunt? Not I shunt, R shunt. R shunt will be equal to Rg into Ig divided by I minus Ig. This is how you will get the value of the shunt resistor, and you can convert a galvanometer into an ammeter. A galvanometer into an ammeter. Also, this ammeter will have a resistance. The resistance of this ammeter will be, these two are in parallel, so it will become Rg multiplied by R shunt divided by Rg plus R shunt. Do we understand what I've written here? First write, first listen, then I will give you time to write. We understand what I've done here? Because any question that comes on this part has to be done by these two equations. Now I can replace this entire thing, and this entire thing actually becomes like this. Dung 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 dung. It becomes an ammeter, and this becomes the resistance of the ammeter. Do we understand what I have done here? Yes or no? No, yes. Do we understand this?
Yes, sir.
I'll give you now 2 minutes to note this down. Here also one more thing. This Ig is very, very small compared to capital I. So if you want to get an approximate answer, you can get an approximate answer by this one. R shunt can be written as approximately equal to Ig Rg divided by I. Do we understand how I've got this approximate relation?
Yes, sir.
Because this Ig is very, very small, you can neglect this literally, and this becomes your shortcut way of getting the R shunt. Now I'll give you 2 minutes to note down this stuff. Let me know once you are done. Okay, then let me give you this question. What is the value of shunt which passes 10% of the main current? 10% of the main current means capital I, that range wala current. 10% of a main current through a galvanometer whose resistance is 99 ohms. So now I'll give you chance to get the answer for this one. I'll give you a minute to do it. So how are we supposed to do this? Find the value of shunt which passes 10% of current through the galvanometer. The only equation that I have told in the galvanometer is this: Ig into Rg is equal to R shunt into I minus Ig. You just have to put the values and get the answer. Resistance of the galvanometer is given as 99 multiplied by Ig. The galvanometer current is 1/10. So if I call the main current as I, it becomes I/10. That should be equal to R shunt into I minus I/10. Just had to put the values here and get the answer. The value of shunt resistance that you will get from here, how much? I think 11 ohms. That is the answer, my dear friends. I hope you have understood how to get this. Have you understood this? Huh?
Yes, sir.
Was it so difficult, sir, that you could not do it, sir?
Sir, we got same, sir.
You said 9.9 beta. This is 11.
That was otherwise answer, sir.
Yes, beta?
Nothing, sir.
Nothing, sir. Okay. Conversion of galvanometer into voltmeter, sir. Conversion of galvanometer into voltmeter, sir. And how do you convert a galvanometer into voltmeter? We connect a high resistance in series. We connect a high resistance in series and we can convert a small simple looking galvanometer into a complicated looking voltmeter. This is Rg and this is R series. And now you can call this entire device becomes what? Amitabh Bachchan.
Volt.
This entire device becomes voltmeter and it can be used to measure any voltage. If I say that the voltage across these 2 points, the maximum voltage that I have to measure is V. Remember, this V becomes the range of the voltmeter. When we are measuring the maximum voltage, the maximum current that can flow here is Ig. So the only equation that you have to remember in this case is, my dear friends, V. Oops, wrong color. I hate wrong colors. V is equal to IG into RG plus R series. That is the only equation that you will have to remember, my dear friends. From this equation, you can find out anything that you desire. Basically, you desire to find out the value of R series. So you can write R series as V divided by IG minus RG. That becomes the exact formula for calculating the series resistance. First listen to me, then I will give you time to write. This becomes the exact formula, but you can write this formula in shortcut for approximate values. Approximately this will become equal to V divided by IG, because RG is very small. So this becomes an approximate formula. And once you find out the value of R series, you can find out the resistance of the voltmeter, and that becomes RG plus R series. And now you can replace this entire stuff. Now you can replace this entire stuff and this entire stuff dung 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 becomes your voltmeter. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
Pakka sir?
Pakas.
Pakka na sir?
Pakas, sir.
Okay sir, then you can note it down sir. You have 2 minutes to show your talent sir in noting down sir. Let's see if you can solve this question from your favorite book. A galvanometer has a coil of resistance 100 ohms showing a full scale deflection current of 50 microohms. What resistance should be added to use it as a voltmeter of range 50 volts, as an ammeter of range 10 milliamps, and your time, good or bad? Bad or good? Starts now, my dear friends. Okay. So let me solve it for you. Voltmeter, the only equation that you must remember in a voltmeter is V is equal to IG into RG plus R series. You just have to put the values, and my dear friends, you will get the answer in this case. V, the voltmeter ka range is 50 volt. That should be equal to the full scale deflection current, that is 50 into 10 raised to the power of minus 6 into RG. RG galvanometer resistance is also given is 100 ohms plus RE RSE. You should not have taken so much of time to give me this answer. The series resistance is 10 raised to the power 6 minus 10 minus 100 ohms. I don't know from where you got plus 100. Maybe in other universe, but in this universe it is minus 100. Now, to get the other answer, the only other equation I know is very simple, and that simple equation happens to be for conversion into ammeter IG into RG. Remember this equation? Yes or no?
0.5 ohms, sir.
Huh?
0.5 ohms.
0.5 ohms. What was the equation? IG into RG is equal to I minus IG into R shunt. So basically that means IG is RG is 100. What I am writing? IG is 50 into 10 raised to the power minus 6 multiplied by Rg is 100. What am I doing? Is equal to current is 10 into 10 raised to the power minus 3 minus 50 into 10 raised to the power minus 6 into R shunt. And I think if you do this, you will get the value of R shunt as approximately equal to 0.5. Everyone got this?
Yes,
Everyone
sir.
got this answer? So as you can see, things are pretty simple if you do things in that way. Everyone understands this? Yes or no?
Yes, sir.
Pakka?
Yes, sir.
Okay, now there are different types of problem that can be done here, and I'm not feeling confident in how you are replying, so I'll have to do more problems. So this is the next one. Can't leave any problem, because if that problem comes and you're not able to do it, this entire exercise goes in vain. So do it fast. A voltmeter has a resistance of G ohm and a range of V volt. Calculate the resistance to be used in series with it to extend its range to N times V volt. So this is similar question but put in a different way, twisted. And I hope you can understand the twist and get me the answer. Is there any hope that you can understand the twist? Twist, 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 twist. Do we understand the twist? Let's see who does the answer, who gets the answer. So what's the answer that you are getting? How are you getting? Now there are different ways of doing it. Now remember, the resistance is given as G ohm and the voltage, the range is V. So from there I can find out the value of Ig, the full scale deflection current. We. The full scale deflection current will become V by G. Yes or no? Huh?
Yes, sir.
I know the full scale current. I need to find out the series resistance. How do I do it? I need to make the voltage to N times V. N times V must be equal to Ig. Ig is V by G into the resistance of galvanometer, which is G, plus the resistance which is connected in series, which is R. Do we understand how I've done this? Yes or no? No, yes.
Yes, sir.
Well done, sir. Good. So your R becomes N times N minus 1 times, sorry, G. And that is the value of register that you have to put to raise the range of this voltmeter from V to N times V. Everyone has understood this. Remember, any one of these questions would appear in one of your papers, in one of your attempts. These questions are in fashion these days. So we must stay with the fashion. And these questions are in fashion. Similar question. You may call it question of electrical instrument. You may not call, you may call it otherwise. Doesn't matter. It's a question of electric current. Question number 4 or 5, whatever. 100-volt voltmeter, that is the range, whose resistance is 10 kilo ohm, so you can understand something, is connected in series to a very high resistor. When it is joined in a line of 110 volt, the voltmeter reads 5 volt. What is the magnitude of 5? Simple question. Now these are the type of question that are in fashion, and we must remain in fashion. I still don't understand fashion, but you must remain in fashion. You are the new gen, next gen. Fashion is important. 2 minutes you have to do your fashion. What do I say? I have no words to say actually. So I will not say anything. In this question, what I'm going to do, without speaking anything, I will try to solve it. So I'll not say anything. I'll just draw and I'll solve. And I hope you understand it. End of story. Everyone understood? Everyone understood what I did? Huh? Yes or no?
Understood, sir.
We have done it so many times, no? 2 registers in series. Find out the voltage drop across this resistor. See, you have become intelligent. The answer is 420 kilo ohms. So what you have to understand is that the questions are simple. You just have to change your perspective. Everyone understood what I've done here, or should I speak and then make you understand? Everyone understood? Yes or no? The total potential drop was 110 volt. 5 volt was across the voltmeter. From there, I found out the value of R. We can do it. Yes or no?
Yes, sir.
Yes, sir. It was so simple, sir. But the question was written in such a way, sir, that you got bamboozled, sir. Anyway, sir, wishing you a happy new year, sir. And I hope that whatever we have done bad in this year, not worthy to be remembered, we shall not repeat it. And you can all take a new resolution to forget something. And that, do you know what you have to forget? Do you know what you need to forget? Yes or no?
Sir,
What do you need to forget?
a bit of forgetting.
The habit of forgetting things. So if you can forget that habit of forgetting things, you still have 24 days to show your worth. And 24 days are good enough to do what you want to do. So I wish you all the best, and I wish that you achieve your dreams in this year. Take care. God bless you. I'll see you in the next year. Bye bye. Take care of
Thank you,
yourself.
sir. Happy New Year, sir.
Happy New Year, beta. Bye bye.
Sir, is there class tomorrow?